Jupiter. The name itself conjures images of grandeur and immense power, a name that echoes with power and majesty. This gas giant is not just another planet, it's a celestial titan. It's the largest planet in our solar system, a colossal ball of gas 2.5 times more massive than all the other planets combined. Its sheer size and mass make it a dominant force in our cosmic neighborhood. This giant plays a crucial role in our cosmic neighborhood. Its immense gravity acting as a shield, deflecting comets and asteroids that might otherwise venture towards the inner solar system, including Earth. Without Jupiter, the frequency of catastrophic impacts on our planet would be significantly higher. But what if this protector, this cosmic guardian, were to collide with another planet? The consequences would be unimaginable, a cataclysmic event that could alter the very fabric of our solar system. Jupiter's gravity is like a cosmic vacuum cleaner, pulling in space debris and keeping the inner solar system relatively clean. This relentless task ensures that the smaller rocky planets, including Earth, remain relatively safe from constant bombardment. It's a thankless job, but someone has to do it, right? Jupiter's role as the solar system's guardian is crucial, yet often goes unnoticed. Without Jupiter, Earth would be a much more dangerous place. The giant planet's gravitational influence extends far and wide, creating a protective barrier that shields us from potential threats. But Jupiter's immense gravity also makes it a target. Its powerful pull attracts not just space debris, but also larger celestial objects that wander too close. Imagine a rogue planet, flung from its own star system, hurtling through the vast emptiness of space. These wandering worlds are rare, but their existence poses a potential threat to any planet they encounter. The odds of it hitting Jupiter are astronomically small, but not impossible. The vast distances and the sheer scale of space make such collisions rare, but they do happen. After all, space is really big. And sometimes things collide. The universe is a dynamic and ever-changing place where even the most unlikely events can occur. Planetary collisions might sound like science fiction, but they're a real phenomenon. These cosmic events have been happening for billions of years and continue to shape the universe as we know it. Imagine the sheer force and energy involved when two massive celestial bodies collide. It's a spectacle of destruction and creation, a dance of chaos and order that has profound implications for the formation of planets, moons, and even life itself. In the early days of our solar system, billions of years ago, it was a chaotic and crowded place. The young sun was surrounded by a swirling disk of gas, dust, and countless small bodies. These small bodies, or planetesimals, frequently collided with each other, merging to form larger and larger objects. This period of intense activity and frequent collisions is known as the Late Heavy Bombardment. Planets were still forming and collisions were commonplace. These violent impacts played a crucial role in the growth and evolution of planets. For instance, it's believed that a Mars-sized body collided with the early Earth, leading to the formation of our moon. Such cataclysmic events were essential in shaping the characteristics of the planets we see today. These collisions played a crucial role in shaping the solar system we know today, determining the size and position of the planets. The gravitational interactions and subsequent impacts helped clear the solar system of debris, allowing planets to settle into stable orbits. Without these collisions, the solar system might look very different. Even today, objects in space collide. While the frequency of such events has decreased since the early days of the solar system, they still occur. Asteroids and comets occasionally collide with planets and moons, creating craters and sometimes even altering the course of their orbits. We see evidence of this in the craters on the Moon, on Mars, and even on Earth. These craters are the scars of past collisions, each telling a story of a moment when two celestial bodies met with catastrophic results. Some of these impacts have had significant effects on the history of our planet, including the extinction of the dinosaurs. These impacts are a reminder that we live in a dynamic and ever-changing universe. The cosmos is far from static, it's a place of constant motion and transformation. Stars are born and die, galaxies collide, and planets continue to evolve. The universe is a vast, ever-changing tapestry of matter and energy. But a collision between Jupiter and a planet would be on a whole other scale. Jupiter, being the largest planet in our solar system, has a massive gravitational pull. A collision with Jupiter would release an enormous amount of energy, far beyond anything we can currently imagine. The energy released would be unimaginable, dwarfing even the largest nuclear weapons ever detonated. Such an event would have profound effects on the entire solar system, potentially altering the orbits of other planets and creating a cascade of further collisions. It's a stark reminder of the immense forces at play in the universe. Let's imagine the unimaginable. A rogue planet, roughly the size of Neptune, is on a collision course with Jupiter. As the rogue planet gets closer, Jupiter's gravitational pull begins to stretch and distort it. The rogue planet is no longer a sphere but a distorted, elongated mass. The impact is sudden and cataclysmic. The rogue planet slams into Jupiter at tens of thousands of kilometers per second. The energy released is equivalent to trillions of nuclear bombs detonated simultaneously. A blinding flash of light visible across the solar system marks the moment of impact. The shockwaves from the impact ripple through both planets. Jupiter's atmosphere is blasted away, revealing the metallic hydrogen layer beneath. The rogue planet is completely obliterated, its material subsumed into Jupiter's massive bulk. The immediate aftermath of the collision is just the beginning. The impact sends trillions of tons of debris hurtling outwards in all directions. Some of this debris is ejected from the solar system entirely, while some remains trapped in orbit around the Sun. The orbits of the inner planets, including Earth, are disrupted by the gravitational shockwaves from the impact. Some planets might be pushed into more elliptical orbits, while others might be completely ejected from the solar system. The asteroid belt, that ring of rocky debris between Mars and Jupiter, is thrown into chaos. Asteroids are sent careening off in all directions, increasing the risk of impacts on planets and moons. Section 5. Echoes of Cosmic Collisions, Lessons from the Past. We don't have to imagine the aftermath of a planetary collision in purely hypothetical terms. Our own solar system bears the scars of ancient impacts. Take the Moon, for example. The leading theory for its formation is the giant impact hypothesis, which suggests that a Mars-sized object named Theia collided with the early Earth, blasting out a massive amount of debris that eventually coalesced to form the Moon. Then there's Uranus, the tilted giant. Its unusual axial tilt, almost 98 degrees, is thought to be the result of a collision with a large object early in its history. These examples are stark reminders that collisions have played a significant role in shaping our solar system. Now, the question that's probably on everyone's mind: what would happen to Earth? The answer, unfortunately, is that it's impossible to say for sure. The universe is a vast and unpredictable place, filled with countless variables and unknowns. While we can make educated guesses based on our current understanding of physics and astronomy, the true outcome remains a mystery. It depends on a lot of factors like the size and trajectory of the impacting object and the exact configuration of the planets at the time of the collision. For instance, a massive asteroid or comet could have a different impact compared to a smaller one. The angle at which it strikes, the speed, and even the composition of the object all play crucial roles in determining the aftermath. In the worst-case scenario, Earth could be ejected from the solar system or even collide with another planet or the Sun. Such events would be catastrophic, leading to the complete annihilation of life as we know it. The gravitational forces involved in such scenarios would be immense, tearing apart the very fabric of our planet. But it's also possible that Earth could emerge relatively unscathed, its orbit slightly altered but still within the habitable zone. In this scenario, life on Earth might continue, albeit with some significant changes. The climate could shift, ecosystems might be disrupted, but humanity could adapt and survive. One thing is certain: even if Earth avoided a direct hit, the consequences of a Jupiter collision would be felt across the solar system. The shock waves from such an impact would ripple through space, affecting the orbits and stability of other planets and celestial bodies. The increased bombardment of asteroids would pose a significant threat to life. These space rocks, some of which could be massive, would rain down on Earth, causing widespread destruction. The impact of these asteroids could trigger earthquakes, tsunamis, and even volcanic eruptions, further endangering life on our planet. The changes in planetary orbits could disrupt the delicate balance of our solar system, leading to unpredictable and potentially catastrophic climate change. The altered paths of planets could affect their gravitational interactions, leading to shifts in their positions and movements. This could result in extreme weather patterns, prolonged seasons, and other climatic anomalies that could challenge the survival of many species on Earth. The hypothetical collision of Jupiter with another planet, while unlikely, highlights the dynamic and ever-changing nature of our universe. It reminds us that even the seemingly eternal celestial dance of planets and stars is not immune to chaos and change. The universe is not a static, unchanging backdrop to our lives. It's a dynamic, evolving system, shaped by forces that we are only beginning to understand. And while these forces can be destructive, they can also be creative, forging new worlds and new possibilities. Thinking about cosmic events like this helps us to put things in perspective. It reminds us of the vastness of the universe and our place within it. We are but a small planet orbiting an average star in a vast galaxy, one of billions of galaxies in the observable universe. And yet, despite our insignificance in the grand scheme of things, we are capable of contemplating these cosmic events, of unraveling the mysteries of the universe. That, to me, is truly amazing. The hypothetical scenario of Jupiter colliding with another planet is a sobering reminder of the power of the universe and the fragility of our existence. But it's also a testament to the resilience of life and the human spirit. We are, after all, a species that evolved on a planet that has experienced its fair share of cosmic catastrophes. So, the next time you look up at Jupiter, that bright beacon in our night sky, take a moment to appreciate its beauty and its power. And remember that we are part of something much larger than ourselves, a universe full of wonder, mystery, and endless possibilities.